July 18, 1944, Normandy, France. The temperature is 22 degrees Celsius, warm and humid after early morning rain that has turned the bocage country roads into slick mud. The hedgerows are thick walls of earth and vegetation, creating a maze of enclosed fields that turn every 100 meters of advance into a separate battle. Staff Sergeant Curtis G. Cullen, a cab driver from New York City before the war, now a tank crew commander in the 2nd Armored Division, sits in his Sherman tank watching the road ahead. His crew has been in Normandy for 6 weeks, and they have learned that the bocage is a death trap for American armor. The hedgerows channel tanks onto predictable routes where German anti-tank guns wait in ambush. When Shermans try to cross the hedgerows themselves, they expose their thin belly armor as they climb over the earthen banks, presenting perfect targets for German gunners. 300 meters ahead, hull down behind a hedgerow with only its massive gun visible, is a Tiger I heavy tank, 60 tons of German engineering, protected by armor up to 120 millimeters thick that American 75 millimeter Sherman guns cannot penetrate from the front. Armed with an 80mm gun that can destroy a Sherman at ranges exceeding 2,000 meters. Crewed by veterans who have been fighting since 1943 and who know exactly how to use the bocage terrain to their advantage. The Tiger has already destroyed 2 Shermans from Cullen's platoon in the past hour. The tactic is devastatingly simple. The Tiger positions hull down where Shermans cannot flank it, because the hedgerows create natural corridors. When American tanks advance down the roads, the Tiger destroys them one by one from positions they cannot see until it's too late. When the Americans try to go cross-country through the hedgerows, the Shermans get stuck climbing the earthen banks, exposed and vulnerable, and the Tiger kills them while they're helpless. Every tactical manual says the same thing. When facing superior armor that you cannot penetrate and cannot flank, call for air support, call for artillery, call for tank destroyers with better guns. Do not engage in direct combat. You will lose. The Sherman's 75mm gun-firing standard armor-piercing rounds cannot penetrate a Tiger's frontal armor. The Sherman's armor cannot stop an 88mm round. The mathematics are simple. The Tiger kills Shermans at ranges where Shermans cannot hurt the Tiger. But air support is unavailable, grounded by weather. Artillery is being reserved for a major operation elsewhere. Tank destroyers are miles away, supporting another unit. And the Tiger is blocking the only road the 2nd Armored Division can use to continue its advance. If they wait for proper support, they lose hours or days. If they try to bypass, they risk exposing their supply column to the Tiger's fire. If they attack conventionally, they lose tanks and men. Cullen looks at the hedgerow in front of his position. 4 feet of packed earth and vegetation, thick with roots, hard as concrete. Impassable for a Sherman using conventional methods. The tank would climb at a steep angle, expose its belly, and die. But Cullen has something no other Sherman in Normandy has. Something he welded onto his tank 3 days ago using scrap metal from German beach obstacles, following an idea that came to him while watching a newsreel about trains before the war. Something so simple that when he first proposed it to his battalion commander, the commander said it would never work. 4 steel prongs, cut from German Czech hedgehogs, the anti-tank obstacles the Germans had placed on the beaches. Each prong is approximately 5 feet long, made of steel I-beam section. The prongs are welded to the front of his Sherman in a configuration that looks like tusks or a medieval battering ram. The entire modification cost approximately 50 cents in welding rod and took 2 hours to fabricate. His crew calls them Cullen cutters. Other tankers who've seen them call them rhino tusks. The battalion commander, skeptical but desperate, authorized Cullen to test the device. The test is about to happen under the worst possible conditions, combat against a Tiger tank that has them pinned down. Cullen keys his intercom. "Driver, when I give the word, head straight for that hedgerow at full speed. We're going through it, not over it. Gunner, the second we're through, you'll have maybe 10 seconds before that Tiger traverses to us. You get 1 shot. Make it count." Over the next 30 seconds, Curtis Cullen will do something that tactical doctrine says is suicidal. He will charge directly at a hedgerow, using his improvised steel prongs to cut through it instead of climbing over it. He will emerge into the field on the other side, flanking the Tiger tank, getting to the side where its armor is thinner and where his 75mm gun has a chance of penetration. And he will prove that sometimes 50 cents of scrap metal and a crazy idea from a cab driver are worth more than all the tactical doctrine in the U.S. Army. How does one sergeant's improvised modification turn the Sherman tank from a death trap in the bocage into a weapon that can challenge the most feared tank in the German arsenal? What was the wire and steel trick that solved a tactical problem that had stalled the entire Allied advance in Normandy? And why did this invention, created in 2 hours with scrap metal, become one of the most important innovations of World War II, copied onto thousands of tanks and changing the nature of armored warfare in France? This is the story of the man who turned a Sherman into a hedgerow-cutting machine, the 50-cent modification that defeated million-dollar German engineering, and the 30 seconds that proved sometimes the best solution to an impossible problem comes not from generals or engineers, but from a cab driver who understood that the shortest distance between 2 points is straight through the obstacle, not over it. While Curtis Cullen was growing up in New York City during the 1920s and 1930s, driving a cab through Manhattan traffic and learning how to find alternate routes when the main roads were blocked, the world was experiencing the interwar period that would eventually bring him to Normandy facing German Tiger tanks. After World War I, Germany had been forced to disarm under the Treaty of Versailles. But by the 1930s, under Adolf Hitler, Germany was secretly rebuilding its military, developing new doctrines and new weapons. German armored doctrine, developed by officers like Heinz Guderian, emphasized speed, concentration of force, and combined arms operations. By 1939, when Germany invaded Poland, the Wehrmacht had perfected Blitzkrieg, lightning war, using tanks and aircraft in coordinated attacks that shattered enemy defenses. The early German tanks, Panzer I, II, III, and I-4, were effective but not dramatically superior to Allied armor. But as the war progressed, Germany developed increasingly powerful tanks. The Tiger I, introduced in 1942, was a quantum leap in armored warfare. With 100 millimeters of frontal armor, an 80 millimeter gun that could destroy any Allied tank, and superior optics and fire control, the Tiger was nearly invincible in direct combat. The United States entered World War II in December 1941 and began developing its armored forces. The M4 Sherman tank, introduced in 1942, was the primary American medium tank. It was reliable, easy to produce, and adequate against early German tanks. But by 1944, it was outclassed by German armor. The Sherman's 75 millimeter gun could not penetrate the frontal armor of Tigers or Panthers. Its own armor could not stop German 75 millimeter or 80 millimeter guns. American tank crews faced the grim reality that they were going into combat in tanks that were inferior to what the Germans fielded. The Allied invasion of Normandy on June 6, 1944, D-Day, was successful in establishing a beachhead, but the subsequent advance inland was far slower than planned. The terrain of Normandy, particularly the Bocage country, created unexpected problems. The Bocage was agricultural land divided into small fields by hedgerows, ancient earthen banks topped with thick vegetation, creating natural walls that were 4 to 6 feet high and often that thick at the base. These hedgerows had been in place for centuries, their roots penetrating deep into the earth, creating obstacles as solid as concrete walls. For armored forces, the Bocage was a nightmare. Roads were narrow lanes between hedgerows, creating channels where tanks had to advance single file. Crossing the hedgerows required climbing over them, which meant exposing the tank's thin belly armor at a steep angle where it was most vulnerable. German defenders quickly learned to position anti-tank guns covering the hedgerows, creating killing zones where American tanks were destroyed as they tried to cross. The tactical problem was severe enough that it threatened to stall the entire Normandy campaign. American armor could not maneuver. German defenders could establish positions that were nearly impossible to assault. The advance that was supposed to cover miles per day was measured in hundreds of meters at heavy cost. Curtis Cullen had enlisted in the Army in 1941 and was assigned to the 2nd Armored Division. He trained as a tank crewman and eventually became a tank commander. He was not an engineer. He had no technical training in armor or weapons design. He was a cab driver who understood how to get from point A to point B despite obstacles, and who was willing to find creative solutions when conventional routes were blocked. By July 1944, after 6 weeks of combat in the Bocage, Cullen was frustrated by the tactical limitations imposed by the hedgerows. He had watched tanks from his unit destroyed trying to cross hedgerows. He had experienced the terror of being channeled into kill zones where German anti-tank guns waited. He understood that if American armor could not solve the hedgerow problem, the Normandy campaign would bog down indefinitely. During a brief rest period behind the lines, Kulin was watching a demolition team clearing German beach obstacles. Czech hedgehogs, large steel structures made from I-beams welded together in an X shape. The hedgehogs were being cut up for scrap. Cullen noticed that the steel I-beams were strong, heavy, and available in quantity. He had an idea. Instead of trying to climb over hedgerows, what if a tank could cut through them? The hedgerows were earth and roots, tough but not as hard as steel. If you could attach steel blades or prongs to the front of a tank and drive straight into a hedgerow at speed, the steel might cut through the earth and roots like a plow, allowing the tank to punch through instead of climbing over. Kulin approached his battalion commander, Lieutenant Colonel William Duncan, with the idea. Duncan's first response was skeptical. "Kulin, tanks weigh 30 tons. You think we can just add some steel to the front and drive through hedgerows that have been stopping us for weeks?" Cullen's response was direct. "Sir, the hedgehogs on the beach are made of steel I-beams. They're strong enough to stop tanks on the beach, so they're strong enough to cut through dirt and roots. I've driven cabs in New York for 10 years. When something blocks your route, you find a way through or around. Right now, we don't have around, so we need through. Give me one tank, some steel, and a welding torch. If it doesn't work, I'll stop bothering you about it." Duncan, desperate for any solution to the hedgerow problem, agreed. "You've got 24 hours. If it doesn't work, we forget about it. If it does work, you're going to have to make a lot more of them." By July 1944, the M4 Sherman was the backbone of American armored forces. It was powered by a Continental R975 radial engine producing 400 horsepower, weighed approximately 30 tons, and had a top speed of 38 kilometers per hour on roads. It was armed with a 75mm M3 gun that could fire armor-piercing, high-explosive, and smoke rounds. The tank had a crew of 5, commander, gunner, loader, driver, and assistant driver, bow gunner. The Sherman's armor protection was adequate against most German anti-tank weapons of 1942-1943, but by 1944 it was insufficient. Frontal armor was 51 mm at the hull and 76 mm on the turret front, angled for improved ballistic performance. But German 75mm and 80mm guns could penetrate this armor at combat ranges. Worse, the Sherman's side and rear armor was much thinner, and the belly armor was only 25mm, the weakest point on the tank. The Sherman's 75mm gun was effective against most targets, but could not reliably penetrate the frontal armor of Tiger or Panther tanks. American doctrine was to use numerical superiority and flanking maneuvers to overcome the individual superiority of German heavy tanks. The saying among American tankers was grim: "It takes 5 Shermans to kill a Tiger. The first 4 die getting the 5th one into position for a flank shot." But in the bocage, flanking maneuvers were nearly impossible. The hedgerows channeled movement. German defenders positioned Tigers and Panthers where they could not be flanked. The result was that Shermans were dying at catastrophic rates. The tactical problem was well understood by American commanders. General Omar Bradley, commanding the U.S. First Army in Normandy, later wrote that the bocage was as formidable an obstacle as we had ever encountered. Armored units were taking casualties that were unsustainable. Something had to change. The hedgerows themselves were the product of centuries of French agricultural practice. Farmers had built earthen banks to mark field boundaries, and over generations, vegetation had grown on these banks, creating walls of packed earth reinforced by deep root systems. The banks were typically 4 to 6 feet high and equally thick at the base. The vegetation on top added another 2 to 4 feet of height. The roots penetrated deep into the earth, creating a matrix that was stronger than the earth alone. When a Sherman tried to cross a hedgerow using conventional methods, the sequence was predictable and deadly. The tank would approach the hedgerow and attempt to climb it. The front of the tank would rise as the tracks engaged the slope. At an angle of approximately 30 to 40 degrees, the tank's thin belly armor would be exposed. The tank would climb slowly, all momentum lost to the steep angle and the resistance of the earth and roots. At the top of the hedgerow, the tank would be silhouetted against the sky, visible from long distances. And if German anti-tank weapons were positioned in the adjacent field, the tank would be destroyed before it could descend the far side of the hedgerow and bring its own gun to bear. American engineers had tried various solutions. Explosives could blast gaps in hedgerows, but this was slow, required engineers to work under fire, and warned defenders that an attack was coming. Bulldozer tanks could push through hedgerows, but there were never enough bulldozer tanks available, and they were slow and vulnerable. Some units tried using grappling hooks and tow cables to tear down sections of hedgerows, but this was time-consuming and only partially effective. What was needed was a device that would allow a tank to punch through a hedgerow quickly, without exposing itself, using its own power and momentum. The tank needed to become its own battering ram. Kulin spent 24 hours fabricating his prototype. He selected steel I-beam sections from cut-up Czech hedgehogs. He cut them into sections approximately 5 feet long. He welded 4 sections to the front of his Sherman in a specific configuration. 2 lower prongs angled slightly downward to bite into the earth at the base of the hedgerow, and 2 upper prongs positioned higher to cut through the upper portion of the earthen bank and vegetation. The prongs were positioned so they would not interfere with the tank's gun or driver's vision. The welds had to be strong enough to withstand the impact of driving into a hedgerow at speed without breaking or tearing free from the hull. Kulin, working with a maintenance section welder, reinforced the welds and added bracing to distribute the stress across the hull. The total weight added to the Sherman was approximately 300 kilograms. Significant, but not enough to dramatically affect the tank's performance. The cost in materials was minimal: scrap steel that was otherwise waste, and approximately 50 cents worth of welding rod. The fabrication time was approximately 2 hours of welding work, plus time to cut the steel sections. The result looked crude: 4 steel tusks protruding from the front of a Sherman, giving it the appearance of a mechanical boar or rhinoceros. Some soldiers called it rhinoceros teeth, others called it Kulin's folly. But Cullen believed it would work because the principle was sound. Steel stronger than earth, momentum and weight concentrated into cutting edges, the tank's power used to drive through the obstacle rather than climb over it. The test came on July 14, 1944, at a training area behind the American lines. Cullen's modified Sherman faced a hedgerow similar to those that had been stopping Allied armor for 6 weeks. Battalion and regimental commanders were present to observe. If the device worked, it would be replicated across the division. If it failed, they would continue searching for alternatives. Cullen positioned his tank approximately 50 meters from the hedgerow. He briefed his driver: "Full throttle. Don't slow down. Drive straight into the hedgerow like you're trying to drive through a wall. The prongs will do the work." The driver, understandably nervous about driving full speed into what appeared to be a solid wall of earth, acknowledged the order. Cullen gave the command: "Driver, move out." The Sherman accelerated toward the hedgerow, building speed. At 30 kilometers per hour, 30 tons of tank struck the hedgerow. The steel prongs bit into the earth. The tank's momentum carried it forward. The lower prongs dug deep into the base of the hedgerow, cutting through roots and earth. The upper prongs cut through the upper bank and vegetation. The tank plowed through the hedgerow like a ship through a wave, earth and vegetation spraying to the sides, roots tearing and snapping. The Sherman emerged on the other side of the hedgerow 5 seconds after impact. The tank was level, not climbing at a steep angle. The belly armor had never been exposed. The crew had maintained visibility and control throughout, and critically, the gun had remained on target, ready to engage threats on the far side. The observers were stunned. The device worked exactly as Kulin had claimed. A Sherman equipped with his steel prongs could punch through bocage hedgerows quickly without exposing itself and emerge ready to fight. This changed everything. General Omar Bradley, informed of the successful test, immediately ordered that the device be mass-produced and installed on every tank in the theater. But there was a problem. There was no industrial capacity to manufacture thousands of steel-cutting devices. The invasion had not included provisions for this equipment because no one had anticipated the hedgerow problem. Bradley made a decision that demonstrated command flexibility. He authorized combat units to manufacture their own hedgerow cutters using any available steel. The primary source would be German beach obstacles, the thousands of Czech hedgehogs and other steel obstacles that had been placed on the Normandy beaches. Tanks would be pulled off the line, steel would be cut from beach obstacles, and maintenance crews would weld the cutters onto tanks. Within 2 weeks, over 500 Shermans had been equipped with Cullen cutters or variations of the design. By the end of July, the number exceeded 1,000. By August, virtually every Sherman in Normandy had some form of hedgerow cutting device. The tactical impact was immediate and dramatic. American armor could now maneuver through the bocage. Instead of being channeled onto roads where German anti-tank guns waited, Shermans could punch through hedgerows, emerging in unexpected locations, flanking German positions that had been considered unassailable. But the true test came in combat against the most dangerous opponent, the Tiger tank. July 18, 1944. Curtis Cullen's Sherman, now equipped with the cutters that bore his name, was part of a task force attempting to clear a road junction defended by German forces that included at least one Tiger's heavy tank. The Tiger had already destroyed two Shermans that had attempted to advance down the road. The Tiger's position, hull down behind a hedgerow with clear fields of fire down the road, was tactically perfect. Any Sherman that advanced on the road would be destroyed before getting close enough for an effective shot. Flanking was supposedly impossible because the adjacent fields were enclosed by hedgerows that Shermans could not cross without exposing themselves. But Cullen had a new option. He could cross the hedgerow into the adjacent field, maneuver through that field behind the hedgerow that lined the road, and emerge into the field where the Tiger was positioned, attacking from the flank where the Tiger's armor was thinner and where his 75mm gun had a chance of penetration. It was still extremely dangerous. The Tiger crew would hear his Sherman punching through the hedgerow. They would begin traversing their turret to engage him. From the moment he emerged from the hedgerow, he would have approximately 10 seconds before the Tiger's 80mm gun was aimed at him. 10 seconds to acquire the Tiger, aim for the side armor, and fire. If he missed, or if his shot failed to penetrate, the Tiger would destroy him at point-blank range. Cullen briefed his crew. "We're going through the hedgerow on my mark. The second we're through, gunner, you'll see the Tiger to our right at about 100 meters. Side shot. You get one chance. If you miss, we're dead. Driver, the second the gunner fires, back us up into the hedgerow. We use it as cover while we reload." The crew acknowledged. They understood the risks. They also understood that this was the only way to kill the Tiger without losing more tanks to frontal assaults down the road. Cullen gave the order. "Driver, move out. Straight through the hedgerow, full speed." The Sherman accelerated, building speed over the 50-meter approach. The steel prongs of the Cullen cutter hit the hedgerow at 30 kilometers per hour. The prongs bit deep, cutting through earth and roots. The tank plowed through, vegetation and dirt spraying away from the hull. The sound was enormous. The roar of the engine, the tearing of earth, the snapping of roots. In the Tiger, 100 meters away, the German crew heard the noise. The Tiger commander immediately understood what was happening. An American tank was cutting through the hedgerow, attempting to flank them. He ordered his gunner to traverse right, toward the sound. The Tiger's turret began its slow rotation. The Tiger's turret traverse was powered but slow, taking approximately 20 seconds for a full 360-degree rotation. A 90-degree traverse would take approximately 5 seconds. Cullen's Sherman emerged from the hedgerow. The tank was level, gun on target, crew ready. The gunner immediately acquired the Tiger, visible at 90 degrees to their right, its massive turret traversing toward them. The gunner could see the 80mm gun barrel swinging in their direction. Seconds mattered. "Target right. Tiger at 100 meters. Traverse right," Cullen commanded, though his gunner was already moving, his hands on the turret traverse controls, swinging the Sherman 75mm gun toward the Tiger. The gunner's sight settled on the Tiger's side armor. The range was approximately 90 meters, point blank for tank combat. The gunner aimed for the junction between the turret and hull, a vulnerable area where the armor was thinner and where penetration might reach the crew compartment or ammunition storage. "On target," the gunner called. "Fire," Cullen ordered. The 75mm gun fired. The armor-piercing round left the barrel at approximately 620 meters per second. At 90 meters range, time of flight was less than 0.2 of a second. The round struck the Tiger's side armor at the turret ring, penetrated and detonated inside the turret. The Tiger erupted in flames. Secondary explosions as stored ammunition detonated. The German crew attempted to bail out, but the fire was too intense. Within seconds, the Tiger was a blazing wreck. Cullen's gunner had made the shot. Total elapsed time from emerging from the hedgerow to destroying the Tiger, approximately 8 seconds. 2 seconds less than the 10 seconds Cullen had estimated they would have. "Back up, back into the hedgerow," Cullen ordered. The driver reversed, backing the Sherman into the hedgerow they had just penetrated, using it as cover in case other German anti-tank weapons were in the area. But there was only silence except for the crackling flames of the burning Tiger. The German defenders, seeing their most powerful tank destroyed in seconds by a Sherman that had appeared from an impossible direction, began withdrawing. The position that had held up the American advance for hours was abandoned within minutes. Word spread rapidly through the 2nd Armored Division. Cullen had used his hedgerow cutter to flank and destroy a Tiger tank. The device was not just useful for mobility, it was a tactical weapon that changed the balance of power in the bocage. What was the real secret to the Cullen cutter's success? How did a simple steel modification change the tactical balance in Normandy? The answer lies in understanding that the device solved multiple problems simultaneously, and that its value extended far beyond simply crossing hedgerows. Post-war analysis by U.S. Army historians and armor experts studying the Normandy campaign identified the Cullen cutter as one of the most important tactical innovations of the war. The reasons were multiple. Mobility. The device allowed Shermans to maneuver cross-country through bocage terrain that had previously been impassable. This restored the mobility advantage that armor is supposed to provide. Instead of being channeled onto predictable routes, American armor could now advance from unexpected directions. Surprise. German defensive tactics in the bocage relied on positioning anti-tank guns to cover predictable routes, roads, and gaps in hedgerows. The Cullen cutter allowed Shermans to create their own routes, appearing in locations where Germans did not expect armor to be able to move. This surprise effect was tactically decisive in numerous engagements. Flanking capability. The ability to cross hedgerows meant that German armor could no longer rely on positioning behind hedgerows to prevent flanking. Tigers and Panthers, which were nearly invincible in frontal engagements, were vulnerable when flanked. The Cullen cutter gave American armor the ability to achieve flanking positions that had previously been impossible. Psychological impact. German tank crews had become accustomed to the tactical superiority provided by the bocage. Their tanks were better, and the terrain prevented American tanks from using their numerical advantage. When Shermans suddenly began appearing from unexpected directions, flanking secure positions, German crews experienced psychological shock that degraded their combat effectiveness. Force multiplication. The Cullen cutter effectively multiplied the combat value of each Sherman. A Sherman that could only attack frontally down roads was of limited value against German heavy armor. A Sherman that could maneuver to achieve flanking shots was exponentially more valuable. The modification turned each Sherman into a more flexible, more dangerous weapon. Cost effectiveness. The modification cost approximately 50 cents in materials and 2 hours of labor to install. Compare this to the cost of a Sherman tank, approximately $45,000 in 1944 dollars, or the cost of developing and fielding new tanks with better guns or armor. The Cullen cutter provided enormous tactical benefit at negligible cost. German responses to the Cullen cutter revealed its importance. German after-action reports from July-August 1944 increasingly noted American tanks appearing from unexpected directions and attacking from flanks despite hedgerows. German defensive doctrine had to adapt, positioning more all-around security rather than relying on hedgerows to prevent flanking. This adaptation reduced the effectiveness of German defensive positions and contributed to the eventual Allied breakout from Normandy. Statistical analysis of tank losses before and after the widespread deployment of the Cullen cutter showed significant changes. In June and early July 1944, American tank losses in the bocage were approximately 3 to 4 tanks lost for every German tank destroyed. After the Cullen cutter was widely deployed in late July and August, the loss ratio improved to approximately 1-to-1 or better. The device did not make Shermans invincible, but it significantly improved their survival and effectiveness. The innovation spread beyond the American Army. British forces in Normandy observed the Cullen cutter and developed their own variations. Canadian forces did the same. By August 1944, Allied armor across the Normandy front was equipped with various hedgerow cutting devices, all based on the same principle that Cullen had demonstrated. Curtis Cullen was promoted to technical sergeant and was awarded the Legion of Merit for his invention. The citation noted that his ingenuity and initiative in developing a device that solved a critical tactical problem contributed significantly to the success of Allied operations in France. General Dwight D. Eisenhower, Supreme Allied Commander, later wrote in his memoirs that the Cullen cutter was a classic example of American inventiveness and the value of encouraging initiative at all levels of command. Eisenhower noted that the device had been invented not by professional engineers or weapons designers, but by a tank commander who saw a problem and developed a practical solution. After the war, the U.S. Army conducted a detailed study of tactical innovations during the Normandy campaign. The Culin cutter was featured prominently as a case study in field expedient solutions to tactical problems. The study's conclusions emphasize several points. Innovation can come from any level. Culin was a sergeant, not an officer or engineer. His solution succeeded because commanders were willing to listen to ideas from subordinates and were willing to test unconventional proposals. Simple solutions are often best. The Culin cutter was mechanically simple, steel prongs welded to a tank hull. It had no complex mechanisms, no moving parts, nothing to break or require maintenance. This simplicity made it reliable and easy to replicate. Field conditions drive innovation. The hedgerow problem could not have been anticipated by peacetime planners. It emerged from the specific conditions of combat in Normandy. The solution had to be developed in the field, under combat conditions, by people who understood the tactical problem firsthand. Speed of implementation matters. From successful test to mass deployment took approximately 2 weeks. This rapid implementation was possible because the device was simple, used available materials, and could be fabricated by unit-level maintenance personnel without industrial support. Curtis Culin survived the war and returned to New York, where he resumed his career as a cab driver. He rarely spoke about his wartime service or his invention. When interviewed by historians years later, he was characteristically modest. "I just saw a problem and figured out a way to fix it. Any tanker in Normandy could have thought of it. I just happened to think of it first and had a commander willing to let me try." When asked about the moment his device helped destroy a Tiger tank, he was matter-of-fact. "The cutter got us into position where we had a shot. The gunner made the shot. The device worked like it was supposed to. That's all." The Sherman tank with the original Culin cutter prototype was brought back to the United States after the war and is now displayed at the U.S. Army Ordnance Museum at Fort Lee, Virginia. The placard next to it reads, "M4 Sherman with Culin hedgerow cutting device. Invented by Sergeant Curtis G. Culin, 2nd Armored Division, July 1944. This simple modification, fabricated from scrap German beach obstacles, solved a critical tactical problem and contributed significantly to the Allied breakout from Normandy. Cost, approximately $0.50 in materials. Value, incalculable." At the Armor School at Fort Benning, Georgia, the Culin cutter is taught as a case study in tactical problem solving and the importance of encouraging innovation at all levels. Instructors emphasize several lessons. Tactical problems require tactical solutions. The hedgerow problem was fundamentally tactical. How to maneuver armor through terrain that prevented maneuver. The solution had to enable tactical flexibility, not just overcome a physical obstacle. Listen to your soldiers. Culin was not an engineer or a designer. He was a cab driver who became a tank commander. His solution came from practical experience and creative thinking, not from formal training. Commanders who dismiss ideas from subordinates may miss valuable innovations. Test quickly, implement faster. From idea to test to mass deployment took less than 3 weeks. This rapid cycle was enabled by the simplicity of the device and the willingness of commanders to move quickly when something worked. Perfect is the enemy of good enough. The Culin cutter was not an elegant solution. It was crude, added weight to the tank, and looked improvised because it was improvised. But it worked. It was available immediately, and it solved the problem. Waiting for a perfect solution would have meant weeks or months of continued heavy casualties. Today, the principle of the Culin cutter, using mechanical force to cut through obstacles rather than trying to climb over them, is incorporated into modern combat engineering equipment. Mine plows, explosive line charges, and modern breaching equipment all reflect the same basic insight that Culin had. Sometimes the best way past an obstacle is straight through it. It is a reminder that innovation in warfare does not always come from laboratories or procurement offices. Sometimes it comes from a sergeant with a welding torch and an idea, working with scrap metal in a field workshop, solving a problem that generals and engineers had not been able to solve because the sergeant understood the problem differently. 30 seconds from hedgerow penetration to tiger kill. 50 cents of welding rod and scrap steel. One cab driver who understood that the bocage was just another traffic jam, and traffic jams require finding alternate routes or making your own. The wire and steel trick, actually steel alone. The wire being the roots in the hedgerows that the steel cut through, that turned trapped Shermans into mobile killing machines. The modification that let a 30-ton Sherman cut through centuries-old earthen banks like a knife through butter. Curtis Cullen, who spent 2 hours with a welding torch and created a device that changed the Normandy campaign. The gunner who made the critical shot that proved the device was not just a mobility aid but a tactical weapon. The commanders who were willing to let a sergeant try something crazy because the conventional approaches were getting men killed. One Tiger tank destroyed, its tactical superiority negated by a Sherman that appeared where it could not be, armed with a gun that could finally penetrate when given the right angle. One device copied onto thousands of tanks, turning the bocage from an American graveyard into a breakthrough zone. The 50-cent modification that defeated million-dollar German engineering. The proof that sometimes the best answer to superior technology is not better technology but better tactics enabled by simple innovation. The reminder that warfare rewards initiative and creativity at least as much as it rewards firepower and armor. 4 steel prongs cut from German beach obstacles. 2 hours of welding. One sergeant's idea that generals initially dismissed. 30 seconds of combat that validated everything. The Cullen Cutter, the device that let Shermans fight Tigers on equal terms by changing the geometry of combat. The innovation that proved sometimes the most important weapon is not the gun on your tank, but the ingenuity of the crew inside it.